Hello, here is Dr. Luca Piciullo from the Norwegian Geotechnical Institute. In this presentation, I'm going to describe you the ongoing 4-year research project on sustainable and safe tailings dams. I'm going to briefly summarize the structure and the main research activities we are carrying out. Tailings dam failures lead, as we know, to huge human, environmental and economic losses. An increasing trend of both failures and volumes of tailings released has been recorded in the last decade. Since 1915, a total of 257 failures have been recorded, with around 2,600 fatalities and 250 million cubic meters released in the environment. The challenges concerning tailings dam safety are several and can be summarized in lack of technical knowledge, monitoring and warning, and tools to manage decisions. Moreover, the uncertainty on the number of existing dams and the fact that in most cases the upstream method was the construction method used increases considerably the risk of catastrophic failures. In this scenario, the main goals of our research project is to improve knowledge on tailings properties, back analyzing past failures and improving monitoring techniques, and also performing triggering and runout modeling and defining risk assessment procedures. The final aim is to increase knowledge and to improve safety and reducing failures. The research project is structured into 5 work packages. I'm acting as project manager, and the colleagues in the photos here are the work package leaders. Let's briefly describe the activities we are carrying out in every work package, and references to journal and conference papers are provided if you are interested to go more into details. One of the tasks for work package 1 is to investigate the possibility of using local waste materials as a water retention material for designing covers with capillary barrier effect solutions. And the research has been performed using column tests where prepared with reactive tailings in the first meter, and we are considering the case study here of Follodal in Norway. The second task of work package 1 is focused on investigating the factors explaining the success or failure of reclamation with capillary barriers of long-time abandoned deposits that are already weathered and partially oxidized. A common approach to limit acid mine drainage from sulfidic tailings is to limit the oxygen fluxes entering the tailing masses, for example with a cover. However, a continuation of sulfide oxidation, even in the absence of oxygen, has been observed in batch tests. And we are suspecting that the presence of secondary iron 3 minerals in old mine tailings is the main cause of unsuccessful remediation. In work package 2, one of the tasks is the geotechnical characterization of bauxite residue and the amelioration with plants. Several column tests have been carried out mixing the bauxite with several amendments to improve the possibility of growing plants. Gypsum and organic matter mixed with bauxite provided a good combination, and plants growing has been observed. In the following months, we will also use X-ray analysis to measure the change in soil porosity and the root characteristics in space and time. A second task in work package 2 is the evaluation of void ratios and strains and shearing mode by different reconstitution methods in silty tailings under triaxial compression by using CT images. We are currently using for these analyses different copper and gold tailings. The CT images are taken during all stages of triaxial testing, from reconstitution, flushing, saturation, consolidation and underloading, and provides valuable quantitative information for better understanding of the specimen's dimension changes. And a comprehensive triaxial testing program is currently ongoing. Work package 3 is focused on the use of numerical modeling for improving the knowledge and predictive capability related to static liquefaction. Back analysis of Fundão dam failure using different constitutive models has been carried out. We have used the Morcullo, hardening soil, and sandy sand. And some of the takeaways are listed on the right here. And in our calculation, the lateral extrusion alone cannot fully explain the failure of Fundão. The change in the phreatic line alone cannot trigger failure easily, and the proper estimation of the state parameter is paramount for a reliable simulation. In work package 3, we are also investigating the tailings dam stability with respect to static liquefaction using sunny sand and Noor sand model, considering a simple dam geometry. Moreover, we are using the response surface method to summarize the results of different scenarios with the aim of defining probability of failure as a function of the state parameter and the phreatic line position. In work package 4, we are assessing the applicability of satellite-based radar interferometry for monitoring tailings dam. We are using data from satellite 1. We are considering two different processing methods, persistent scatter and small baseline subset. S-bus method provides better coverage, but the PS method has more accurate measurements, but the coverage is sparse. Several tailings dams have been analyzed, and for Zelazny most, a decomposition of vertical and horizontal displacement has been computed. Another activity of this work package was focused on the use of the inverse velocity to try to predict failure. We applied the method to two failures, Cadia and Feijão, and here we see the results for Feijão. We considered a long-term monitoring interval and not only the period right before the failure. And the method proposed by Carla et al. 2017 has been used to define when to apply the inverse velocity. Our results show that without knowing the failure day, it is difficult to avoid false alarms and to effectively predict the failure day. Moreover, we believe that INSAR monitoring technique is not suitable in the case of liquefaction. In work package 5, we computed statistics of tailings dam failures using an up-to-date dataset, a correlation between dam factor, considering dam height, and stored volume, with the released volume has been carried out. You can see the result on the figure on the top, and the figure on the bottom shows the dependency of the released volume by the dam height and stored volume. Moreover, the contingency table on the left at the bottom shows that upstream dams are more prone to static and dynamic liquefaction. Runout analysis have been also carried out in this work package. If a tailings dam fails, the tailings can travel many kilometers, as we know, posing a risk to infrastructure, the environment, life and health of the affected people. Modeling the mobility of liquefied tailings is challenging but yet essential task for estimating the elements at risk and consequences of dam failure, and it may be also relevant for the GSTEM assessment. This figure presents an example of a runout simulation of the Feijão mine tailings dam modeled using Bean-Claw code developed at MGI. The volume of the input source area was estimated by interpreting the topography before and after the failure. And the figure superposes the extent of the tailings deposit at the end of the sliding based on the interpretation of satellite images. And you can see the red contour here in the figure. There is a very good agreement between the simulated runout and the observed one. The final aim of this work package is to integrate the runout analysis into a quantitative risk assessment of people exposed. The objective, concluding, of the project is to reduce the risk associated with tailings dam with tailings dam facilities by improving the knowledge on chemical and geomechanical properties of tailings, providing a better understanding of their behavior, improving the predictive capabilities related to static liquefaction, and then also developing a methodology for using remote sensing and INSAR data into monitoring and early warning, and developing a risk assessment and management framework using the available statistical data, observations, and conclusion from early tailings dam failure. If you are interested to collaborate or to know more, please reach out by sending me an email. You can see my email on top of this slide. And here are the references if you want to go more into details. Thank you very much.